Section 1.7 is on midpoint and distance formulas, and we're going to look at two different midpoint formulas. One, if you're just dealing with a number line. If you have two coordinates, you know the endpoints, to find the midpoint, add the two endpoints together and divide by 2. So basically find the average. When we go to two dimensions, a coordinate plane where you have x and y and it's a slanted line, you have to find the average of the x values and the average of the y values. So the formulas to know are a plus b divided by 2, and this more complicated one where you take the two x values and divide by 2 to get the x value of the midpoint, take the two y values, add them together, divide by 2 to get the y value of the midpoint. Okay. So let's look at some examples. Line segment AB has endpoints at -4 and +9. What is the coordinate of its midpoint? So to find midpoint, when we're just dealing with a number line, the midpoint equals the two values added together, -4 plus 9 divided by 2. -4 plus 9 is 5, divided by 2, which is 2.5. So the midpoint of this segment over here is at 2.5. Okay. Now when we start dealing with a diagonal line with x and y, to find the midpoint, we're going to take the two x values, so the 7 and the 2, add them together and divide by 2. And then we're going to do the two y values, which is 5 and -4, add them together, divided by 2. So the midpoint, 7 plus 2 divided by 2, so 7 plus 2 is 9 divided by 2. 5 plus -4 is 1 divided by 2. So the midpoint is 9/2, 1/2. If you want to put it in decimal form, which I prefer fractions, but if you need to think about it in terms of a decimal, just to kind of be able to see where it's at, that's fine. So 4.5, 1.5, or sorry, 4.5, 1/2 is about right there. Okay. Let's look at the next couple here. Line segment JK has endpoints at -12 and 4 on a number line, so they're only giving us two things. So to find the midpoint of JK, we're going to take -12 plus 4, divide by 2. -12 plus 4 is -8, divided by 2 is -4. And if we have line segment RS, now we're dealing with an ordered pair, an x and a y. So to find the midpoint of that, we're going to take the two x values, 5 and 3, add them together and divide by 2, and the two y values, -10 and 6, so -10 plus 6 divided by 2. So 5 plus 3 is 8, -10 plus 6 is -4, so our midpoint, 8 divided by 2 is 4, -4 divided by 2 is -2, so our midpoint is at 4, -2. So that's the gist of the midpoint formula. Now, if we know the midpoint and one of the endpoints, we can use the midpoint formula to find the other endpoint. This is a little bit more complicated, but not too bad. So if we know the midpoint is at -2, 1, and one of the in C is at -5, 7, find the other end of this segment, the other endpoint. Okay. So using the midpoint formula, so the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, we only know one of those x values. Now remember, the midpoint is a value xy as well. So the midpoint is negative 2, 1. The x value that we know is negative 5. So I'm going to put that in for x, one of the x's. And the y value that we know is 7, so I'm going to put that in for one of the y's. Now, for this to be true, the negative 2 has to equal negative 5 plus x over 2. So I'm going to set negative 2 equal to negative 5 plus x over 2. And I'm going to set the negative 1, the 1 equal to 7 plus y over 2. So now I have two things to solve. To solve them, in both of them, we want to multiply by 2. So we have negative 4 equals negative 5 plus x, and we have 2 equals 7 plus y. So to solve this, to solve each of them, this one we're going to add 5 to both sides, so x would equal 1. On this side, we're going to subtract 7 from both sides, so y would equal negative 5. So our endpoint is at 1, negative 5. Oops, right about there. Okay. So point D is 1, negative 5. So if we look at the second one, we don't have a graph for this, but we don't need one because remember the midpoint for negative 9 is going to equal the x values, so negative 3 plus the x value we don't know divided by 2. And then the y value that we know is negative 5 plus y divided by 2. So the x values have to be equal. So 4 has to equal negative 3 plus x over 2. And negative 9 has to equal negative 5 plus y over 2. So again, we're going to multiply by 2 to get rid of the fraction there. So I'd get 8 equals negative 3 plus x. And 2 times negative 9 is negative 18 equals negative 5 plus y. So we'd have to add 3. So x is going to equal 11. And this, for the y, we're going to have to add 5 to both sides. So negative 13 equals y. So what are the coordinates of B? B is going to be the point 11, negative 13. Now we're going to talk distance formula. Okay. You've done distance formula before, I believe. But if you haven't, that's not a big deal. This is the distance formula, and you need to know this. Okay. It comes from, the reason we can use the distance formula is basically because of the Pythagorean theorem. Okay. Which I know you did in 8th grade. Dealing with a right triangle, finding the difference between the x's, finding the difference between the y's, so this is where we get the distance formula. I say, you need to know that. You have to memorize, memorize, memorize. Okay? So let's do some examples with it. What is the distance between u and v? So, the distance formula, like I said, you got to memorize it, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, it doesn't matter which of the points is x1, y1, and which one is x2, y2. So we'll just go in order, x1, y1, x2, y2. So distance equals the square root, x2, is 4, x1 is negative 7, y2 is negative 3, minus y1 is 5, square that. So we have to simplify inside the parentheses first. So 4 minus a negative 7 is the same as 4 plus 7, so 11 squared, plus negative 3 minus 5 is negative 8 squared. That's going to give me 121 plus 64, which is equal to 185. Now, at some point we'll talk about how to simplify that, but for now I just want you can just take that square root and plug that into a calculator to get an answer. And if you plug that into a calculator, you get about 13.6 for the distance. Okay. So let's look at A down here. SR, line segment SR, has endpoints of negative 2, 14, and 3, negative 1. So we're going to do distance equals the square root x1, negative 2, minus x2, 3 squared, plus y1, 14, minus y2, negative 1. Let's square that. So that's going to equal the square root. Negative 2 minus 3 is negative 5. 14 minus a negative 1 is the same as 14 plus 1, which is 15 squared. Negative 5 squared, remember, when you square something, you're multiplying it by itself. A negative times a negative is a positive. So when you square a negative number, you're going to get a positive number. So 25, 15 times 15 is 225. So we end up with the square root of 250. Again, we're just going to put that into a calculator, and we get about 15.8 for a distance. Okay. Now, if we look at B just for a minute, suppose we switch around and let the point V be the x1, y1, and U be x2, y2. Would you get the same result? And the answer is yeah. Because we square those differences anyway, basically if you switch them around, you'd get a negative number maybe instead of a positive, but because we're then multiplying it by itself, it doesn't matter whether it's negative or positive. Okay, so it doesn't matter which point is x1, y1 and which point is x2, y2, you will get the same result either way. Let's look at one more example. So here's a zip line course. You start at platform A and zip to each of the other platforms. How far do you travel from B to C? So we need to find the coordinates of B and the coordinates of C. Okay. So let B be x1, y1 at negative 30, negative 20. Saved a little time here. C is at negative 15, 10, and that's going to be x2, y2. So our distance equals the square root of x2, negative 15, minus x1, negative 30, squared, plus y2, which is 10, minus y1, negative 20, squared. So the distance then equals, negative 15 minus negative 30 is the same as negative 15 plus 30, which is 15. 10 minus a negative 20 is 10 plus 20, which is 30 squared. I'm going to shorten that a little bit. So we get the square root of 225 plus 900, which is the square root of 1125. So again, we're going to take the calculator and figure that one out. and we get 33.5. Now, each grid represents 5 meters. So this is the distance on the grid, but to get our total distance, we actually have to multiply that by 5. So the from B to C is 167.5 meters. Okay? Okay, sorry I didn't look at the graph right. It's saying each grid is 5, but they actually have it marked that way, and I didn't think they did, so no, we're good. So just 33.5 meters. I'm going to skip the got it there, just because of time, and I'm just going to go ahead and let you get going on your assignment, which is posted on Schoology.